All right, I'm here with Santosh, and we're in the reliability lab. And tell us what you do here. You break things, I take it.
Yeah, so here what we attempt to do is we try and design reliability and quality into our products. So most of the stuff that you see here is you see where we are trying to break things and make sure that when our end customers are not able to break stuff.
Yeah.
So when we talk about reliability, we have two aspects to it. One, when the customers get our products, they have to, it must feel good to them.
Yeah.
That's the perception of the quality. That's what we call quality at time zero. And then customers expect that our product should operate, period, at all conditions, wherever they're going to use. So we work here with the user interaction group, user experience group, to understand what the customers' expectations are from our products. Like for example, this is a Rio mouse. So here there are a number of features in this mouse. For example, the users are going to use the buttons, they're going to scroll the wheel, they're going to be using this mouse in a mousing fashion for a number of different surfaces. Mm-hmm. So when it comes to an end user, they have a perception of, okay, this feels good, this feels bad, and we expect that this should last, say, like 3 years or 4 years or whatever that lifespan is. So those are the information that we get from customer surveys and things like that with the user experience group does. What we do here is when this is being conceptualized and when the designers are working on making the shell models and making the product, so we make sure we do a lot of tests, we do a lot of prototype tests here. We essentially design the reliability into the products. So we make sure that, for example, the forces meet the customer specs, the torque of the wheel meets the customer specs. So I'm going to walk you through all the test equipment that we have here. So right here in the entrance we have what we call as the Q-Sun Sun Expo UV tester. So what this does is our mice units are used in office environments. It can be used in outdoor environments. So what happens is our mice, they get exposed to sunlight, they get exposed to office lights and things like that. Because of that, over time, what happens is you have your plastics degrading, you have discoloration of plastics and things like that. Here we run an accelerated test where we actually expose these products to different wavelengths of sunlight and office ambient lights. So this test, we run it for a couple hours, like 200 hours, and it roughly gives us an acceleration of what happens to this when it is exposed for 3 years. So that way, before this goes into it goes into production and goes into the end user, we have tested this the exposure and the robustness of the plastics to UV.
Cool.
Here you see a bunch of microscopes. These are all microscopes of different magnifications and different capabilities. We do a lot of drop tests and we do thermal cycling tests on all of our hardwares. So here we actually inspect for failure sites and failure mechanisms and what caused the failures. So if we look at the failure pictures, if we see how the failures have occurred, what we can do is we can figure out and we can provide information to the design team as to what they can change so that the failure doesn't occur. So this is where we actually look for failures and capture failures in using these equipments. You must have already seen this one. This is called as the mouse tracking system. Mm-hmm. So basically, you have a navigation in all of our mice. This basically checks the how good the navigation is on different surfaces. So one aspect of reliability engineering is we make sure that our products meet the life expectancy of users. So we know for a period of 3 years how many times the users are going to use the buttons. So here we do a test during our prototype, during our EV PV stage, EV through DV stages, where we actually measure the life of the buttons. So it's basically what we do is this test goes on for millions of cycles, actually 2 to 3 million cycles.
Does it drive you guys crazy in here to hear this?
We have a quiet chamber, so yeah. It's placed in. So the next lab that you see, it's basically where we have high noise equipment and things like that.
And how many cycles does it take before you find that the average button fails?
We test for, like, for example, we test up to 3 to 5 million, even sometimes 10 million, depending on what the hardware unit is and what we expect our customers to use. So the test can last anywhere between 2 to 3 weeks, sometimes more.
Yeah.
But in our test spec, we rarely see a failure. If we see failures, it's usually beyond our design life.
Yeah, I'm not going to push a button 10 million times, so, that should be good.
Yeah, you're not going to break it.
Yeah.
I can tell. Here we have what we call the torque measurement system. So one of the features of most of our mice is the wheel. So and when you scroll the wheel, the amount of force that you put to scroll the wheel is an indication whether the wheel feels good or bad.
Yeah.
So we have done a number of tests, and we have understood what the users, what spectrum of torque values the users like. So this is a station where we actually measure the torque and make sure that our products are meeting that those requirements. So I'm just going to start the test here. So it's a simple test setup, which actually there's a wheel that drives it, and it measures the torque of the wheel. So this just goes on for like 3 to 6 minutes or something. Over here we have a flat table. When users are in a mousing mode, one of the annoyance factor is if the mouse has a tendency to rock. So a poorly built mouse will rock from side to side, and the users can feel it.
Yeah.
So we have a spec on how much a mouse can be allowed to rock, and we use this flat table and some feeler gauges to basically measure the rock on our mice.
So is this a super flat table?
This is super flat table.
Nice.
It defines flatness and what a flat surface is.
Yeah.
So this becomes our reference of measurement for anywhere where we need flat surfaces for whatever measurement we are looking for.
Very cool.
We use this. This is a height gauge where we use to measure different dimensions and things like that. Over here, we have what we call a paint abrasion test. So you can see this logo that we have on our mice. So as users are using this for many months, there's a tendency for the logo to abrade. So if the logo goes off, it's an indication of a poor quality or it's a bad perception of the quality.
Yeah, you don't want it to be worn.
Yeah. So this is an accelerated test that we do where we actually, right now I'm not going to test this, but I can kind of show you how it's gonna abrade it. So we put a specific load on the abrasion tester, and there's a certain number of cycles it has to pass where the logo should not abrade.
Yeah.
So we make sure that our products meet those specs before they get shipped out. Over here, okay, so I'm sorry. This is where we actually measure the force to fire. When we say force to fire, it's basically the amount of force it takes to click the mouse. So here we have a simple load tester, which basically applies force on the mouse primary left and right buttons, and it measures the force.
So is it always the same between mice, or is there a different amount of force for some mice than there is for others?
It's typically we have, it depends also on the size of the mouse, but we have a sweet spot for each mouse that we try to achieve.
And you find that users have some kind of sweet spot in mind that, they know what they like.
Yeah, the UX, the user experience group, early on in the program, they kind of work with some consumers and stuff like that, and they try to come up with what that sweet spot is.
So do gaming mice have a different one than business mice?
Yeah, so we worked on a gaming mice like 2 years ago.
Yeah.
So there we had different kinds of buttons where, especially on the side button, you had vertical buttons. So users had a very different perception of a feel for those buttons. So we were able to figure that out and design it.
You don't want to accidentally hit those when you're trying to frag someone.
Yeah.
Okay.
So all of this have been tested here, and we made sure that it meets those specs.
Cool.
So This is our cable life tester. This is only for wired mouse. So when you have a wired mouse and you are scrolling it over a number of over many months and many cycles, what happens is the cable flexes at this point, and it has a tendency to fail. So we make sure that the strain relief and the cable that's designed meets our 3-year life spec. So it's a simple test where you have a suspended load, and this is what it's emulating how a mouse will be used, and this has to go through a certain number of cycles, which basically tells like if 10,000 cycles is for 3 years, we test it for 10,000 cycles, and we make sure that the cables are meeting our specs. Here, this was a specifically custom-built torque life tester for webcams. So this was a webcam which we released last year. So one of the mechanisms that you have is you have a mount on top of which you can mount on top of the monitor, and you have a mechanism that basically swivels it. So this basically tests how many times you can swivel it. So we have a spec for this that it has to last this many swivel cycles.
Yeah.
So during actual production, prior to production, we make sure this design is going to meet that specification. Rest of the stuff that you see here is basically tools and workstations and soldering stations, multimeters to basically aid in all the failure analysis and failure work that you do there. So you can see that our products have all this cool looking paints and it looks really good. And one of the things that you don't want your products to have is stains as you use over many months. So staining is an indication of a very poor quality. So what we do here is we have a chemical withstand test. So we basically have 12 different chemicals which are the common constituents that are found in a human hand in an office environment. It can be Coke, coffee, Vaseline, lotions, perfumes and things like that. So we expose our colored plastics to those chemicals, and we have a test procedure for that, and we make sure that there's no staining that happens. So that's called chemical withstand test, and that's done here. So what we have here is a drop tester where we can drop our products, PC hardware products and Zoom products from different heights. We do drop by hand also, and also specific drops at specific orientations. So we drop this through multiple different orientations. So the objective of drop test is basically to understand how robust our products are.
Yeah.
And in products like this, they do fall out of your pockets, or if you're carrying it, it has a specific drop height where products will fall off of. So any products that we design here, we make sure that they pass a certain drop height spec, and this is where it's tested. We have a standard office environment carpet that we use as the impact surface for all these products, and there you can basically see how we have a high-speed video camera which is placed and which captures a drop phenomenon.
Nice. So you can see how an arc mice takes a hit.
Yeah, you can see how an arc mice takes a hit. If you see a failure, you can see how the stress patterns are going, and we can know where we need to tighten it up. We also do a lot of finite element simulations, which is basically a numerical analysis method, and it's a very effective tool that we use. And we use this much ahead, even before EV builds, basically. So we can numerically simulate how the products are going to last, say for a drop impact or thermal cycling loads and things like that. So specifically for a drop impact, we can use these high-speed videos and our numerical simulation models to see how good we have simulated a drop, and it provides a lot of useful information to the designers, which we can make it very robust instead of building a lot of products and testing it to failure. Cool. So drop test, this is a very valuable piece of.
How high do you normally drop things from?
Again, it depends on like for a wired mouse or a wireless mouse or a presenter mouse, Zune, it can range anywhere from 1 meter to 1.5 meters. So again, we look at what is the most possible height from which a user can drop this product.
And do you always drop it onto this office carpet, or you use different surfaces? And
For mice, we use the office carpet because
That's typical.
It's a
Yeah.
typical environment. But we have used other like concrete surfaces, like for mobile products and things like that, for Zoom products and things, other hardware units. But yeah, that carpet surface is a reference surface against which we test, and we also get the manufacturers to test.
cool.
And one last piece of equipment. So what you see here is the KeyLife keyboard tester. This is probably the most noisiest machine. And our keyboards, there has been instances where we have tested up to 20 million cycles, anywhere from 5 million to 20 million cycles. And this test can go anywhere from 30 days to 40 days. It's basically pneumatically driven, and all it does is that. So I have just a few plungers testing a couple of keys, but we can cover a lot of keys with this one, and we basically make sure that it meets our life requirements and our reliability requirements. So that's kind of the gist. What I wanted to show, there's another lab which is kind of closed right now because construction work is going on, but we'll have a lot of thermal chambers. So in thermal chambers, what we do is we test our products so that it lasts shipping conditions. It can last our normal usage environment where thermal excursions can happen. So any humidity excursions that can happen, we have a bunch of different thermal and humidity chambers where we have specific tests that we do for our products.
Cool.
So that's kind of what I wanted to show. Is there any specific questions you have?
Yeah, well, thanks for showing us this. This is
welcome.
awesome.